I think the hardest cases to investigate are where there are no witnesses to the initial stages of the fire, or in situations where you're trying to understand the layout of a scene and the circumstances leading up to a fire in terms of what equipment was left switched on, who was a smoker, what were their activities in the period immediately leading up to the fire. So examples of that could either be remote properties, but they could also be properties where there's been a fatality and the fatality was the person who has that knowledge. So they're quite difficult because there are a number of factors that conspire. One is you don't have that knowledge of the scene when you start off on the investigation, so you can't narrow down your area of interest in terms of what you're looking for. You don't know the activities that could have led up to the fire, because certain activities are more hazardous than others. Of course you don't get that early information as to where the fire was first seen, or there may have been no early discovery of the fire. So it could have been a well-developed fire before anyone was alerted to it. So generally speaking, those are the more difficult cases to deal with. There are a number of things you can look at. The obvious one is the unexplained presence of flammable liquids in the fire debris. Other signs can be evidence of stacking of combustible materials to make a bonfire, or it could be, in the case of commercial premises, the removal of stock beforehand. Intruder alarm systems are a very useful means by which you can identify whether a fire is of suspicious origin or not, because they often will log when they were last set and unset, and that information might show whether there was an unexpected visit to the premises 10 minutes before the fire was discovered. So all these factors can be indicators of a deliberate fire as opposed to an accidental fire. Additionally, the security status of the premises is a key indicator as to whether there's been any untoward activity before the fire. So often when the fire service arrive at an incident, one of their concerns is how they get into the building for the purposes of firefighting. But an aside to that is that they will make observations that allow us as investigators coming along later to establish what the security of the premises was when they arrived. So if they see any doors that are ajar, or any windows that are broken and fires venting out of them, that can give us an indication as to untoward activity. I don't think there's any one particular item. The most important thing is the investigative process, the thought process involved in investigating fires. In terms of the actual tools, I would say that the best one is something as simple as a good source of light. Often fire scenes are very black by their very nature, and the electricity supply will invariably have failed, whether to the building as a whole or to the room of origin. So you're often working in very dark conditions, and so in order to fully appreciate the pattern of fire damage, which in itself can inform you as to where within the room the fire started, you do need to be able to see the room in best detail possible. It depends on the material that you're sampling. Generally speaking, most common flammable liquids, such as petrol and diesel, are non-polar, which means that they are best retained in bags which are of polar polymer nature. So nylon bags are typically used for collecting samples of fire debris where petrol or diesel or similar is suspected. Those bags are quite unusual in terms of getting hold of them. They are specialist bags, and we have to go to forensic suppliers to get them. If it's a polar solvent that we're looking for, then a non-polar bag, such as a polyethylene bag, it will suffice. So it's a case of choosing the right sampling bag for the right material that you're interested in. Having said that, it does rely on the investigator to make a judgment as to what it is that they think is in the fire debris, but generally speaking, the most common liquid used to set fires would be petrol or diesel, so we always carry a collection of nylon bags for that purpose. Well, I think you need to take sensible precautions, ensure obviously you have clean kit, although the prospects of actually carrying over any flammable liquid contamination from one scene to the next is very low in any case, because the levels that you are looking for when you analyse the samples are relatively high compared with the sensitivity of the instrumentation used to do the detection. What you get when you burn materials is, as well as the combustion products, carbon dioxide and water, you also get a lot of products of incomplete combustion, and that provides a sort of a background noise of different compounds that are present when you analyse the fire debris for the presence of petrol residues, for example. So you do need quite a lot of the flammable liquid to be present to be seen above that background level, and hence the reason why cross-contamination generally isn't an issue. But as I say, you take sensible precautions, so you will segregate samples. So when you take your sample of suspect fire debris, you will obviously change gloves in between taking that sample and then taking a sample to act as a control from a separate area. You'll make sure that those samples are stored away from each other, and generally keep the samples segregated until such time that you do have the samples analysed. And also, as a further control, you will often submit a bag that you took the samples in, a bag of the same type, so that any sort of background influence from that bag can be accounted for during the analysis. We use a variety of labs. It depends primarily on the technique that we need in terms of the level of detail. For example, just to confirm the presence of petrol, it's sufficient to use gas chromatography on its own, and that's quite a sort of a cheap and cheerful analysis. Whereas if you need to determine an unknown flammable liquid, then you may need to look at GCMS, gas chromatography, mass spectrometry. So that's a more expensive technique, and fewer labs will have that equipment, although they are still quite readily available. And then there may be specialist analyses such as petrol brand analysis, where you can take some fire debris and try and identify what brand of petrol was used, so that if you have a suspect who has been seen purchasing petrol within the period leading up to the fire, you can compare what they've bought with what was used in setting the fire. It's to do with the economies of scale. We don't have enough samples to justify maintaining our own lab on a sort of day-by-day or week-by-week basis. We often use outside suppliers for different services, such as the labs to analyse fire debris. We bring in, for example, intruder alarm engineers, where there's a particular requirement to interrogate an intruder alarm panel from a premises. Likewise, if we have some fire debris that's basically a lump of melted plastic with some electrical components inside it, before we start hacking away at that to try and find the evidence that may lie within it, we may subject that debris to X-ray radiography, basically take an X-ray of it. So again, we take that to a laboratory that has those facilities. We don't just investigate fires either, we investigate material and mechanical failures, and a lot of their work involves the use of scanning electron microscopy to examine fracture faces, for example. So again, if you take into account all the different techniques that we do use, we would have to have a very big lab and go to great expense to kit it out, whereas it's far more financially efficient just to pick and choose these external facilities as and when we need them. In terms of our own understanding and knowledge of fire investigation,
Yes.
we disseminate information. So, for example, if a particular appliance, if we see it cropping up with frequency, let's say go back to the example of a dishwasher. If we see a particular manufacturer's dishwasher is cropping up on our system again and again, it may be that someone will investigate a fire involving that appliance, might not come to any firm conclusions because of the damage is so extensive, whereas on a subsequent investigation someone else might see one where the damage isn't so far progressed and may be able to find a particular feature which shows the specific cause on that appliance. That information then gets sort of disseminated throughout the group, and the person who had the first one can go back and revisit their appliance to see if they've missed anything now that they know what to look for.
Mm.
So there's that general dissemination of information throughout the group, and also we do maintain an extensive technical library. We employ a number of librarians in our London office to maintain that. That has various journals in it, dealing with fires and obviously the other subject areas that we investigate. It has records of all the tests that we've done over the years on various matters. So it's a very useful source. It has technical documents such as building regulations, British standards, so that where you're looking at a failure of a piece of equipment, you can compare how the equipment was designed or performed and compare that against what is required of such equipment by the building regulations or the British standards. I think the general principles of what causes a fire are well recognised, so there's nothing particularly new in that aspect, but individual causes on specific cases may require you to dig a bit deeper into the specifics of that case. For example, you can have fires caused by self-heating of certain materials when stored in bulk. Now, the two main factors that determine whether a material will self-heat to the extent of spontaneous ignition are, first of all, its reactivity, of course, but the two factors that you can control are the size of the bulk material and the ambient temperature. What you'll find is that for a given ambient temperature, the bigger the size of the bulk, the more likely a material is to self-heat. Likewise, for a particular bulk size, you'll reach a critical ambient temperature above which that material can then undergo a self-heating reaction. So when you come across something that you've not seen before, or where there's no documented results for a particular product, then you can submit that to testing to determine what those limits are, to understand more specifically about that particular issue on that particular case. I think sniffer devices, electronic noses as they're sometimes called, have limited use in that they're only as good as the person using them, and the person using them has a perfectly good nose on the front of the face to do the same. Generally speaking, if you want to detect levels of flammable liquids that are above the background levels of the products of incomplete combustion, you can usually detect that by your nose. I can think of cases where I've carried out an excavation of the scene where a fire officer was using an electronic nose. We cleared an area away from a particular window where we suspected something had been introduced through that window. And it was only when I went back to investigate what looked like a slightly raised lump on the floor and then pulled that up that it absolutely reeked of petrol. Now this was based on sort of intuition that, you know, we've cleared so far back and we really ought to have found something by now. that area had been cleared and the electronic nose had been deployed at every stage, and it shows that it's not perfect. Allied to the use of electronic devices, you can get dogs that are trained in the detection of common flammable liquids. And they can be quite effective when you've got a large area to screen. So if you've got a large industrial building that's become well involved in fire before the fire service arrives, so there's no clear information as to where the fire started, but you might have found the petrol can outside to indicate that there's something untoward there. Then you can bring a dog in, and that can screen a large area, and they can be quite effective in identifying those areas to then investigate further. You dig down and then start pulling the debris up and sniffing it and sampling where necessary. So you don't go into a scene and just take samples of debris on the off chance that there might be some accelerant there. You are guided and you do take an intelligent decision as to that. And there are some cases where you might suspect the use of a flammable liquid, but you can't physically smell anything either with your nose or with an electronic nose, but it may still be worthwhile taking samples of debris to analyse in the lab. For example, I mentioned petrol brand analysis earlier. The components that they add to petrol are not particularly volatile, so that whilst the petrol itself may have evaporated or been burned to completion during the course of the fire, the additives that some manufacturers add may still be present, and you can look for those on samples of debris. Take, for example, the situation of someone introducing flammable liquid through a letterbox. There may be quite extensive damage just inside the doorway and no discernible odours remaining from that fire, but these additive fingerprints might still be present. I don't think you can point to one single development because it's a discipline that's continually evolving. It sort of develops incrementally. So it's a field of expertise where you need a breadth of knowledge because it crosses a number of disciplines. It crosses combustion chemistry, physics, physical processes such as heat transfer, electrical failure investigation. So you need a broad knowledge across all those different areas in order to investigate fires. And if there is something novel in a particular fire that you're investigating that requires more specialist input, then you can speak to one of your colleagues who has that relevant expertise, or you can do some additional research that deals specifically with that matter to resolve the issues that have arisen. I think you need good practical knowledge. All people who work for us will have some technical degree, so that's their sort of core technical discipline. But it helps if you have a broad knowledge of matters that are outside that specific discipline. So, for example, to know how the electrics in a house are wired. I'm a chemist, but I knew before joining Burgoyne's the broad principles of that. You might need, it wouldn't harm you to know how engines work. All these sort of different areas where you can sort of use that breadth of knowledge to apply to the problems that you have to solve as an investigator. And then the third quality is to have that natural ability to investigate and to solve the problems that arise, and to not leave the matter until you've resolved any sort of discrepancies in the evidence or rationalised what you've found by and what you've been told by witnesses, until you're satisfied that you can explain the two together. So it's that sort of tenacity in carrying out the investigation. Well, generally, investigations are carried out on an hourly fee rate, but of course you've got to ensure that the costs of the investigation are proportionate to the size of the loss. So in certain cases it is proportionate to carry out a preliminary examination of a fire scene to reach a stage where you're able to advise your clients, who for our purposes are generally insurers, as to whether there's any merit in carrying out further investigations. So, for example, insurers might wish to know whether or not the fire was deliberate on the part of their policyholder, obviously, but they may be interested to know whether there is a potential recovery against the manufacturer of a particular item that has caused the fire, or whether someone carrying out work at some premises has carried out their work negligently and that's led to a fire. So if the case appears to be at a dead end and going nowhere, insurers can stop any further investigations at that early stage, or they can then authorise further investigations.